Hello everyone, myself Gopi Rajakkannu Ravi. I am here to present my topic, which is entitled as the novel synthesis of two-dimensional ion intercalated MXENE by molten salt etching method. And first of all, I thank to the IMRC organizing team and my university for the wonderful opportunity. And before we move on to our material, here let me see the objective of my work. And here we are synthesizing ion intercalated mixing using a monochloride salt, that is CuCl, and which is successfully achieved. And further, the material is exfoliated using ultrasonic waves to get a good interlayer spacing. And the electrochemical analysis is performed to understand its behavior for the energy storage devices. So first of all, let we see the methodology. In the methodology, it involves mixing of the all the mixtures in the ratio of 1:6 is to 2 is to 2. The max phase and the Cl, that is monochloride salt, is mixed in 1:6 ratio, and the molten salts are mixed in 2:2 ratio. And the mixture is placed in the crucible, and the crucible is heated at 700 degrees Celsius for 8 hours in tubular furnace under nitrogen atmosphere so that the material won't oxidize. And further, it is cleaned with HCl and ethanol so that we can remove the presence of the molten salt and CuCl. Mm, the material is further ultrasonicated for 2 hours to exfoliate the material so that we can increase the interlayer spacing, and the solution is dried in oven and powdered to get a powder form of MXENE. These are the possible reactions of the MXENE, which shows how the aluminum is removed, that is aluminum chloride is formed and evaporated during the synthesis, and how the Cu as well as chlorine is intercalated as well as terminated in the MXENE. Now we can move to the resultant discussion. In the characterization, first we see the structural and elemental analysis. Here I have presented the SEM images before and after ultrasonication, and you can see before ultrasonication the materials, that is the particles, are bulk, and the particles are not uh, well uh, exfoliated, the interlayer spacings are less, and after sonication the particle well broke and the interlayer spacing is increased. And from XRD pattern you can observe the downshift of 1 degree in the primary peak 002 from the max phase, and you can also see the eradication of aluminum peak and also broadening of all the peaks, which shows uh, the shows the formation of MXENE. And also we have identified the presence of Cu, which could be expected as the pre-intercalated MXENE. To further confirm the pre-intercalation of copper ion, the EDS and XPS is performed. From the EDS, we can see the composition of the elements as well as the presence of Cu. The presence of Cu is around 6.4, which is very less, and the presence of Cl is 1.2, which is not equal. So we can possibly say that the chlorine is terminated in some in surface, and Cu may be intercalated in between the layers. And the small presence of aluminum shows that some of the in some places the max phase is not completely etched to form MXENE. So the presence of aluminum is very less, around 0.18 percentage. And this is the mapping, elemental mapping from the EDS. And to further confirm, the XPS is performed, and you can see the presence of copper, that is carbon, niobium, chlorine, and aluminum. You can see the intensity of aluminum is very less, so the content is very less, and the presence of oxygen is due to the moisture content present in the powder sample. And you can also see the presence of copper as well as chlorine, and this is the deconvoluted peaks from the XPS. Here we have also performed the surface area analysis, that is bed analysis. From bed we have calculated the surface area as 4.12 meter square per gram, and pore size as 14 nanometer, which is around in the mesoporous range. And the isothermal plots shows that the the curve shows hysteresis loop of fourth category. And further, the electrochemical analysis has been performed to understand the behavior of the material for energy storage devices. And here the CV and GCD curve shows the shape of these curves shows diffusive behavior, and the EIS graph shows the conductivity of the material, where the ESR, that is electrochemical series resistant, is 0.48, which is very less, so the material has a good conductivity. And the shape of the EIS graph also shows a battery-like behavior, where the 40-degree line is not present, but there is no much resistivity. And also the specific capacitance over the scan rate is plotted, and also for the current density is plotted for GCD. The maximum specific capacitance is achieved on scan rate of 5 millivolt per second, which is 175 farad per gram, and the maximum specific capacity from the GCD is achieved from current density of 1 ampere per gram, and it is around 135 farad per gram. The also the reversibility of of the material, and as well as to confirm the diffusive behavior, the logarithmic graph and scan rate over the current graph has been drawn. The R square value is nearly closer to 1, so it has a good reversibility. And the B value is around 0.59, so uh, it has a diffusive behavior. If it is capacitive, it should be around 1. And further, we finally we can move to the conclusion. And from all those findings, we can confirm the synthesis of the niobium carbide MXENE, and further it is exfoliated through ultrasonication. And from XRD, the shift and the broadening is confirmed, as well as the presence of Cu. And from the EDS and XPS, the elemental compositions and the presence of Cu is confirmed and identified. The surface area and the pore size is calculated from the bed analysis, which is 4.12 meters square per gram and 14 nanometer. The maximum specific capacity and the diffusive behavior is analyzed from the electrochemical analysis, as mentioned earlier. And the EA shows a good conductivity, and from the logarithmic graph, the B value is calculated as 0.59, which is also good diffusive behavior. And from the current state of this work, we have successfully proved that CuCl could be used to synthesis the MXENE through molten salt etching. And to further investigate the involvement of pre-intercalated ions as well as further intercalated ions, uh, the two electrode systems and further um, device fabrication is needed, and also theoretical studies like molecular dynamics is needed, which could be performed in the future to understand the charge storage mechanism and efficiency of the electrochemical and electrochemical performance. And myself and my team members acknowledge Conosite Mexico for scholarship, and these are the reference I have used primarily used for this work. Thank you.